Assalamu alaikum and hello, my dear children. Let's begin an exciting session on acids and bases. Today, we will focus on understanding what acids, alkalis, and pH scale is, inshallah. So let's aim to score some stars. Acids are a type of substances, of course, or compounds. They are specifically solutions, okay? They are solutions of certain compounds. They are solutions of certain compounds. Please understand that acids, they are solutions. Solutions that produce H plus ions. Now, H plus ions, even though they are ions, they are made from covalent molecules. Even though these H plus ions, they are ions, but they are made from covalent molecules. Like supposing you have a compound called HCl. Say you have HCl. Now, what is HCl? It's a gas, isn't it? And it is a white fumy gas. Now, if this gas is bubbled, okay, gas, let's write the state symbol. And if this gas is bubbled through water, now water is liquid. So if it is bubbled through water, it becomes aqueous. It becomes aqueous. So what do you mean by aqueous? Aqueous is something that is dissolved in water. So what happens when HCl gas is bubbled through water? It becomes aqueous solution, and that solution where you have HCl being ionized. Now, what does it become? It becomes H plus ions and chlorine ions. So what do you mean by ionized? Ionizes means it becomes ions from not being ions. So ionizes in water. It ionizes in water. Actually, there is a change of bond happening here. It goes from covalent. So this is covalent. It goes from covalent to ions. So they don't form an ionic lattice. Remember, they don't form an ionic lattice because the ions are freely moving in this form. So aqueous hydrogen ions. And remember, this is the key. This is the key. Like, for example, when hydrogen and group 7. So what are group 7 now? Group 7 elements are your halogens, right? If you dissolve them, when you dissolve them, like for example, let's take a few examples. When you add, that is when you add water, when hydrogen and group 7 elements are dissolved, when they are added in water, let's take a few examples like HCl, okay? It becomes aqueous. So here this HCl gets ionized. So it becomes H plus ions and chlorine ions. If I have to kind of react hydrogen with bromine, so hydrogen bromide, what will happen? It will get ionized into hydrogen and bromide ions. So likewise, let's take another example, hydrogen iodide. So hydrogen ions plus iodide ions. So this is, ionization, wherever you have the hydrogen ions being produced. So let's take another popular acid, which is HNO3, nitric acid. So what happens to nitric acid in aqueous? It gets ionized into hydrogen ions and nitrate ions. So this you need to learn, all these ions, you have to kind of learn them. So ionize means they become separated into ions. So here you see the acid gets separated into ions. So we are concerned about hydrogen ions now. So in this chapter, we are not concerned about chloride ions, bromide, iodide, or nitrate. We are not concerned about these anions. We are concerned about hydrogen ions. So now acids, they behave in a certain way. So what makes it an acid? It's because of these hydrogen ions. So let's say these hydrogen ions which are here are an active ingredient of an acid. Let me show you another famous acid, sulfuric acid, H2SO4. So when it gets dissolved in water, you have hydrogen ions produced. But then, here you have two hydrogens. So two hydrogen ions are produced here. And of course, you have sulfate ions, which are also produced. So here there are two hydrogen ions produced. So now what do you understand from this? So what do you think is the definition of an acid? So acids, they have to make acids. This is like a definition, okay? A part of the acid definition. Acids have to make hydrogen ions. Of course, they in solution, okay, in aqueous. So you have to, this is a part of the definition for an acid. Now you guys need to know a few of these anions like chloride ions, bromide, iodide, nitrate ions, and also sulfate. And apart from this, you also need to know carbonate. These are all the anions which you need to learn by heart. Like for your IGCSE chemistry, whether it is Edexcel or Cambridge, you have to kind of remember this. So you have the carbonate. These are the carbonate ions, and this is hydroxide. So this is hydroxide, something which is very important, which you need to know. So here comes the definition for an acid. So this is the definition for an acid. A substance that dissolves in water. As I told you, they are solution. They are solutions of certain compounds. Acids are certain solutions. So that should be dissolved in water, producing H plus ions. And of course, a solution that about the litmus paper, we will learn in a few moments. Now, acids have to make hydrogen ions. They have to. Now, what is the opposite of an acid? What is the opposite of an acid? It's an alkali. It's an alkali. Okay. So the opposite of an acid is an alkali. And what is an alkali? It has to make hydroxide ions. It has to make, of course, again, in water. It has to make hydroxide ions in water. So when I said opposite, it means acid is giving, it's giving hydrogen ions. So what should alkali actually do? What should alkali actually do? Because I said it's opposite of acid. So alkali should take hydrogen ions, isn't it? It should take hydrogen ions. And that's right. Technically speaking, an alkali takes in hydrogen ions. Okay, so let's put it this way. So the definition of an acid is a substance that dissolves in hydrogen ions, the substance that dissolves in water, producing hydrogen ions, and it is a proton donor. So hydrogen here is the proton and it gives. So acids, they give. So therefore, acids are proton donors. They are proton donors. So now what are alkalis? Now I'm sure you must be able to recall alkali earth metals, like, you have alkali metals, the group 1. What are group 1 elements called in the periodic table? They are the alkali metals. They are the alkali metals. So now what we are going to concentrate on are the group 1 hydroxides. We will be concentrating on the group 1 hydroxides, which are very, 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 very soluble. They are highly soluble in water. Okay, so these hydroxides, they're very soluble in water. Now, let me maybe give a few examples. Let me give you a few examples, like sodium hydroxide, potassium hydroxide. So what does potassium hydroxide ionize into? It gives away K plus and OH minus. Okay, so these are group 1 elements, and the hydroxide ions. Here, water, like if I put aqueous here, the water changes the state, but it is not a part of the reaction. Okay, so let's take NaOH now, sodium hydroxide. So sodium hydroxide, of course, it needs to be dissolved. It is solid, but it needs to be dissolved. It needs to be dissolved in H2O. So as I said, water is changing the state, but it does not take part in the reaction. So here you have sodium ions in aqueous. So sodium hydroxide gets ionized into sodium ions and hydroxide ions. Okay. So what is the definition of an alkali? So this is the definition of an alkali. So what is the definition of an alkali? They are soluble bases that produce hydroxide ions in water. Okay, coming to litmus blue and the indicator, we will see them in a very few moments. So today, now what have we learned? We have learned acids are substances that dissolve in water, and they produce hydrogen ions. And because they produce hydrogen ions, they act as proton donors. And alkalis, they are soluble bases that produce hydroxide ions in water. Okay, so a few of the ions that are present, let's kind of review them. So acids, we learned about hydrochloric acid. What are the ions that are present? They are hydrogen ions and chloride ions. Nitric acid has hydrogen ions and nitrate ions. Sulfuric acid, hydrogen ions, and you have sulfate ions. So then if you talk about alkalis, a few famous popular alkalis are sodium hydroxide, potassium hydroxide, calcium hydroxide, and ammonia solution, which has ammonium hydroxide in it. So you can see that you have sodium ions, potassium, calcium, and ammonium ions. And what is the main ingredient of an alkali? It's the hydroxide that it produces. So these, we need to identify which is an, if you are asked which is an acid, which is an alkali. So the main thing that you will look for are hydrogen ions. So these are your hydrogen ions. So you will look for the hydrogen ions and you look for the hydroxide ions. So the ones that give out hydrogen ions are acids. And the ones that give out hydroxide ions are alkalis. So the next thing that I need to know is the strength. So first is identification. How will I identify? How will I identify which is an acid or an alkali? Is by this, that whether it produces hydrogen ions or hydroxide ions. And the next thing is I need to know the strength of these acids or alkalis. Like I need to know how strong they are. Like how acidic or alkaline these are on a scale. So let's say how strong or weak an acid is. So for this, we have a man-made scale. We have a man-made scale and we call it the pH scale. So it's like a number line. So can you see? It's like a number line. And it starts with, it starts with the 7. It starts with 7. And that number, this pH is called neutral. Okay, so here you go, anything below 7, is called acidic, and anything above 7 is called alkaline. So let's just write that down. Okay, so here it is acidic, this is acidic, this is neutral, 7 is neutral, and above 7 becomes alkaline. So this pH scale depends on the type of acid, okay, the type of acid, and also the concentration of, the acid. So like, for example, if you see water is neutral. It has a pH 7, and also a few salts, they are neutral. Like, for example, NaCl, sodium chloride solution, they are neutral. And anything, now if you see the weak acids that you have, weak acids, now what do you mean by weak acid? So weak acid, they have very less hydrogen ions. They have very less. Okay, let me just push this up a little so that I get some space to write. Okay, so here you go. Okay. So what do you mean by weak acids? Now, weak acids are those which have less hydrogen ions. They have less hydrogen ions. And what are strong acids? Strong acids are the ones which have lots, they have lots of hydrogen ions. They have lots of hydrogen ions. And what are weak alkalis? What are weak alkalis? So here you go. Weak alkalis are the ones which have less hydroxide ions. And which are the strong alkalis which have lots of hydroxide ions. So for a substance to be neutral, the pH should be exact 7. So pH should be exact 7. So here you go. When a substance has a pH of 7, it means that the hydrogen ions are equal to hydroxide ions. And in an acidic solution, hydroxide ions are lesser. Or in other words, hydrogen ions are more in number than hydroxide ions. And in an alkaline solution, in an alkali solution, what happens? The hydroxide ions are greater than the hydrogen ions. So these are a few things which you need to remember, and do take screenshots and or you draw these pictures in your notebooks so that you can easily remember things. So there are a few tips by which you can remember these things. And the easiest way to detect whether a solution is acidic or not is to use an indicator. Now, what's an indicator? Indicators are substances that change color. They change color. They change color. When do they change color? They change color if they are put in an acid or an alkaline solution. And there are 3 common indicators which you should know in your syllabus. They are litmus, thymophthalene, and methyl orange. Now, what is litmus? Litmus is extracted from lichens. And it becomes purple in neutral solution. So whenever it's a neutral solution, it becomes purple. That is pH 7, it becomes purple. And when an acidic solution is added to it, it turns red. It turns red. And the color, this color change of litmus is the result of the chemical. There is a chemical reaction that's going on, and substances with opposite chemical effect to acids are needed to reverse that change. And these are called bases, like alkalis. So what happens in an alkali? Like when you use litmus to test an alkali, it turns blue. Now, an easy way to remember this is, see, this is the effect of litmus paper. The acids turn litmus paper to red, and bases turn litmus paper to blue. A simple visual memory aid is this. Like acid, if you want to remember, it has a D, so red. So litmus paper turns red. And base has a B. So alkali or base. Inshallah, we will kind of learn more about the difference between a base and an alkali, which will be done in the next video. So don't forget to watch that video. So acids, they have a D, so it becomes a red, and base has a blue B, so which is blue. So bases turn litmus to blue. Another commonly used indicator is the universal indicator. Now, this indicator is a mixture of, the universal indicator. It's a mixture of many indicators. Now, why is this important? Because it gives a range of colors, like depending on the relative strength, very, very specific. If you see here, it gives, for specific pH, there is a specific color. So that's a universal indicator here. So the more acidic solutions, they turn to red. So there is, 7, which is green. And if you see they are highly acidic, like pH 0, it turns to a bright red. And the less acidic solution, like for example, a vinegar, will only turn universal indicator to orange, yellow, or orange. So there are also color differences produced with different alkali solutions. So the most alkaline solution gives a violet color. It is important, children, to realize that the pH scale is a logarithmic scale. So this is a logarithmic scale in which the two adjacent values, like for example, 6 and 7 or 7 and 8. So these adjacent values change by a factor of 10. Each pH unit means a 10-fold difference in hydrogen ion concentration. An acid of pH 1 An acid of pH 1 has 10 times the hydrogen ion concentration of an acid of pH 2. So this is what you need to understand. This is a man-made scale, and it is 10-fold difference. So between 1 and 2, there is 10-fold difference. Between 2 and 3, 10-fold difference. So this is important that you understand this. Before we end this session, let's take a quick quiz, to test our understanding. So, take your time to pause this video and write these answers down. So what do you understand by the word corrosive? So acids are corrosive. So what do you mean by the word corrosive? So which acid is present in orange or lemon juice? If you want to do a little bit of browsing, do a little bit of research and answer these, but do answer them. What acid is present in vinegar? So methyl orange is an indicator. What does this mean? Is a solution acidic, alkaline, or neutral if its pH is 11, 7, 8, or 3? Which solution is more acidic? An acid with a pH 4 or an acid with a pH of 1? So I want you to answer these questions. Pause the video and answer these questions. So once you have answered them, make sure to check the answers. Thank you for watching my video, and please do be connected for the next session where we will discuss the differences between an acid and differences between alkalis and bases. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuhu.